Hello, this is Mr. Yoon, and today we will be learning how to estimate the value of square root of non-perfect squares. Now, although there are many different ways to estimate square root of non-perfect squares, today I will be showing you two different ways. And before we get to that, let's talk about the key phrase for today. So the key phrase for today is to find two closest perfect squares to estimate square root of non-perfect squares. So here are some key vocabularies that will be used in this lesson. First is square. In this case, throughout this lesson, square will not mean the shape where all sides have the same length. In our situation, for this specific lesson, it will be used as power of 2. So for example, over here we have 3 to the power of 2, but it can also be read as 3 squared. And the next definition is rational numbers. Rational numbers are pretty much whole numbers, negative numbers, 0 decimals, with ending or patterns, and fractions. So for example, 1.4 is a rational number, 3 over 4 is a rational number, negative 7.4 and negative 3 are all rational numbers. Then there's also irrational numbers, and those are pretty much decimals without end or pattern. And the most famous example of irrational numbers are pi and square root of 2. If you plug these two numbers in calculator, you'll find that pi is 3.1415 blah 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 without any specific pattern or an ending. And also, if you put square root of 2 into your calculator, you will get a decimal that will not have any ending or pattern. And now, what is square root of 2? We will talk about it more in this lesson. And here are a couple more definitions on the back. So perfect squares are square of rational numbers. So for example, 1 is a perfect square because 1 squared is 1. And 4 is a perfect square because 2 squared is 4. And 9 is perfect square because 3 squared is a 4. 3 squared is a 9. 1.44 is a perfect square because 1.2 squared is a 1.44. And 9 over 4 also is a perfect square because 3 over 2 squared is 9 over 4. And next is square roots. So I will talk about square roots in more detail, but for now, you can think of square roots as opposite of squares. So over here, and we use the symbol over here. So this is read as square root of 4, and we know that 2 squared is 4. And as I said before, opposite of square is a square root. So square root of 4 is 2. And square root of 1.44 is 1.2. So first, let's try to estimate the square root of 40 using a number line. So if you look at the number line here, in blue, I have something that you would see on a regular number line from 1 to 9. And on top on green, I have written down its squares. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on and so on. So first thing that we have to do is we have to figure out where 40 would be in between. So I know that 40 is in between 36 and 49. So then I know that square root of 40 also has to be in between 6 and 7 because square root of 36 is 6 and square root of 49 would be 7. So now let's look more closely into a number line where in between 6 and 7. So I know that 6.5 would be halfway in between 6 and 7. And on top, I have 36 and 49. And I've also written down 40 on top as well. So I know that from 36 to 40, there is a gap of 4 because 40 minus 36 is 4. And from 40 to 49, there's a gap of 9. So then I know that 40 is much closer to 36 than it is to 49, which means that square root of 40, which will be underneath here, is going to be slightly more closer to 6 than it is to 7. Then roughly, now there are many various answers that you can give, but roughly an estimation, so around 6.3, will be a good estimate. So any answers ranging from 6.2 to 6.3 would be a fairly solid estimation. Now, drawing a number line to estimate the square root of a non-perfect square can be little time consuming. So here's a different method using a times table. So let's say the question asks you, what is the square root of 40? So what we're going to do is we look at the times table, and we know that the numbers on the diagonal of the times table, which is highlighted in blue, are all the perfect squares. And we're just simply going to find two numbers that will have 40 in the middle. And in our case, in this case, we know that 40 is going to be in between 36 and 49. And let's see what square root of 36 and 49 are. So if you follow to the left, we know that square root of 36 is a 6, and square root of 49 is a 7. So then I know that square root of 40 has to be in between 6 and 7. And now I also know that 36 is about 4 smaller than 40, and then 40 is 9 smaller than 49. So again, we followed the same process. We know then 40 needs to be closer to 6 than it is to 7. Then what's a reasonable estimate? So I know then anywhere in between, again, same as before, 6.2 to 6.3 will be a good estimate of square root of 40. So let's summarize how to estimate a square root of non-perfect squares. So the first step is find two perfect squares that are the closest to our number. And step 2 is you got to figure out how close our number is from two perfect squares. And the last step is you just have to make a reasonable estimate based on step 1 and 2. That's it for today. If you have any questions, feel free to ask. Bye.